So we're given, first of all, the f of x function, which has a range of -1 to +2. So I've just kind of drawn the min and max points of this range of f of x to start with. So what's the range when we do the transformation, where we do the absolute value first, we do a vertical flip, and then a shift of +2. Okay, so first thing is, when we do the absolute value, that red coordinate is going to end up being reflected in the x-axis to +1, and we have now the bottom of that is going to be, so imagine this being a linear function, the bottom of that would be now at the x-axis. So wherever it crosses the x-axis is now the bottom of that function. So that's the first thing. Now we have this range from here to here. So the next step is we're going to flip it across the x-axis, and we're going to end up with the point. That red point goes back to where it started with, and the blue point now is going to be down here. It's going to have the bottom of that coordinate, or the bottom of that boundary, is going to now be at, we do that again. The bottom of that boundary is going to be at -2. Okay, so we now have our range that is between 0 and -2. So what ends up happening then is, the last step is, we're going to shift that all up to +2. So this point he gets translated up to 0, and the highest point gets translated up to +2. Okay, maybe I'll do that in a different color here. That highest point gets translated to +2. So now our new range is going to be back to the lowest point is going to be at 0, the highest point is going to be at +2. So the range values are going to be from 0 all the way to +2, and since the boundary points were included in all cases, that's going to be our new range. For the next one here, we're going to do the inverse. Inverse is really just switching our x and y. So I'm just going to rearrange this expression. Instead of y equals, I'm going to make that x equals. So this represents our inverse expression. Now we want to express this as an inverse, so we need to solve for y. So I'm going to first of all subtract 5, divide by 3. Once I do that, I can now convert it into this log form. So the inverse of this original exponential is a log. So this log form now looks like this. Log base 2 of the argument, x minus 5 over 3, is equal to y minus 2. And then solving for y is equal to log base 2 x minus 5 over 3 plus 2. Okay, so I can then write it as, with the inverse notation, the inverse of f of x is a log base 2 of x minus 5 over 3 plus 2. For example 10, we're starting with the coordinates 6 and 10, and we're going to do the following transformation. We're going to do inverse. We're going to multiply that by 1/2, and then we're going to do a horizontal shift of -1. So we can do the x and y coordinates separately. So starting with the x, what's happening is the only x transformation is a +1 transformation. So it's going to go from 6 to, sorry, it's a +1, so it's going to go from 6 to 7. +6 to +7. For the y transformation, we're going to multiply by 2 and then do a reciprocal. So I'm going to take that value of 10, I'm going to multiply it by 2, I get 20. So I end up with 1 over 20 as the y coordinate of that transformation. And again, I just need to separate what's happening with the x with what's happening with the y.